Okay, let's move on to problem number 4. Problem number 4. A coin is tossed 25 times. So you got this coin here. We're going to toss it 25 times. Estimate the chance of getting 12 heads and 13 tails. What is the probability of getting 12 heads? Okay, if we get 12 heads, we're going to automatically get 13 tails, so we can just ignore that. So we're just going to ask for the probability of getting 12 heads. There's an exact way to calculate this from a previous chapter, but I think they want us to use the probability or the normal distribution curve because that's what we've been looking at. So let's just draw one of these things. And the expected value then on 25 tosses of getting 12 heads, probability of one head is 1 out of 2. So 1 out of 2 times 25 is 12.5. That's going to be our expected value. And so basically, if we're going to get 12 heads, what we're going to do is we're going to the area under this entire curve to the left of the 12.5 is the probability of getting from 0 all the way up to 12.5 heads. Well, we want only 12 heads, period. So we're going to subtract 1 from this, and that's 11.5. And we're going to take the total area to the left of this 12.5, and we're going to subtract the area to the left of this 1.5. So then all we're left with is a probability right here of getting exactly 12 heads, not less or not more. And so we need to standardize these two values here so we can look in our table to find out what the area is under the curve for these things. Okay, right off the bat we know that, well, let's go ahead and standardize these things first. So our z value is equal to, again, the observed value, and we'll just take it for this one right here. We know that this is halfway in the curve, so the area under the entire curve is 1. Well, half of this area to the left is going to be 0.5, and I'll just show you how it works in the formula so you believe me. Your observed value is 12.5. Subtract your mean value, 12.5. I don't think that's going to work. And divide this by I don't think that's going to work at all because we're going to have 0. Yeah, let's just scratch that. Okay, we know that half of this curve is 12.5, so half of this curve is 0.5. And so if we just take that 0.5 and subtract this area here, what we'll have is left is the area for 12 rolls. So the z value, if we're going to standardize the 11.5, we take the 11.5 minus 12.5 and divide that again by our standard error. Standard error is equal to the square root of 25, the number of draws, times our standard deviation, which is, in this case, anytime you have a 0 and a 1, the standard deviation is a half, and you can calculate that, or you can punch it in your calculator. But the square root of 25 is 5 times 1/2, which is the standard deviation, is equal to 2.5. So if we take this down here to the next step, you have minus 1 over 2.5, and minus 1 divided by 2.5, that's equal to 0.4 minus 0.4. So right here, the value is minus 0.4. So if we look in the table for the area to the left of minus 0.4, that should give us 10 comma minus 0.4. It should give us like 0.3446. 0.3446. So if we take 0.5 and subtract that, we should get equals 0.1554, and I'll change colors for the final answer, times that by 100 is equal to 15.54%. Okay, and that should be the chance of getting exactly 12 heads. I'll see you in the next video for problem number 5.